Hi, I'm Jeffrey Vetter from Oak Ridge National Lab and Georgia Tech. At both organizations, what I'm doing is looking at next generation architectures in terms of software and hardware so that we can map our important applications to what we see coming down the architecture pipeline. We're excited about Keeneland. Last year we wrote a proposal to the National Science Foundation, who has some vision here, and said we want to look at things off the traditional roadmap. And when we did our alternatives analysis, we found that GPUs were a great solution because they're a commodity solution. They provide a lot of floating point performance for quite a few different applications, and they're becoming more programmable. That's been a big challenge in the past, but over the past 2 years, the programmability has become much better. With CUDA coming along, it's made a huge impact. I, in fact, taught a class a couple years ago at Georgia Tech of graduate students, and I gave them the choice of programming their HPC problems on, Blue Gene or Cray XT. About 25% of them picked a GPU and downloaded CUDA in some cases and ran it in their dorm room. And so the accessibility is an important aspect of all that. We actually came up with a matrix that has the different inherent structures or features of each of our applications in it. And we listed probably 100 applications, and then we went through and started prioritizing them and started looking at DCA++, looking at combustion codes, and there's probably 4 or 5 more right now that we're starting to look at that we think will map well to the GPU. The future is more fun than it has been in computer architecture. So some of the trends I mentioned earlier about looking at exascale in both DOE and NSF and other places, we're trying to figure out if we want to build an exascale system in the 2018 timeframe, what is it going to take? And if you take the technical trends that the current components are projected at, it'll just be too much power, and it'll cost too much, and it may be unreliable. And so what we've been looking at are alternatives to that, and one alternative is heterogeneous processing, and the benefit there is that you use the silicon more efficiently, and you can build smaller, more high-performing systems with less power that solves your problem in the same or better amounts of time. And so, I think in 10 years, every system will be a heterogeneous processor. How it's exposed to the user, there's still some debate there, but that looks like a promising path forward.